Welcome to today's lesson. We are still under chemistry and we are going to complete this chemistry this week. All right. So trust the process, trust the preparation, trust everything. Trust me. Trust my track record, trust my achievement. Okay. So if you are a JAMB UTME candidate 2026 and you have not been preparing, or you've been preparing late preparation, early preparation, I can help you. Don't fail this JAMB UTME. Don't do what? Don't fail this JAMB UTME. The experience no go sweet. Make the right adjustments. All you need is my lesson notes and my lecture, my explanation, and my short plan for last minute preparation. That's what you need. This very simplified notes, very short, straight to the point. As you read them, no, you don't read finish. If you get laptop, use your laptop till you read them. If you get phone, use your phone till you read them. No excuse. Anywhere you can read. If you deal with your friends, just carry your phone, navigate, just put one or two things inside head. All these are powerful key points tailored for the JAMB UTME syllabus, leaving no stones unturned. You can't take my lecture, join them. Everything will just come gel. Everything will just come go where, guys. Don't snooze on this. You can get this lesson notes. It's available in physics, chemistry, biology, and English. Don't fail. Okay? Don't fail this JAMB UTME for no reason. Even though you get only 2 weeks to prepare, I can still help you pass. I tell you. All you need is your mind and your time. Bring your mind, bring your time. Take my lessons, take my lesson notes, use my plan. If you don't get time again, use my short plan. My short plan for last minute preparation for JAMB UTME is available. Lesson notes are available. Very short, straight to the point. Your full JAMB syllabus will long like what I don't know. I don't compress them into 350 slides for each subject. So what are you waiting for? Send me a DM. Check the comment section. You are going to see the phone number to DM, or go to my profile. Okay, you are going to see my phone number there. Send me a DM and get your copy. Don't fail this JAMB UTME. See, my core, the main thing why I do now to prepare students of the last minute candidates. Preparing last minute candidates, that's what I do best. And I've been doing this for more than 4 years now, or for almost 4 years. Be serious. This time around, be serious. I can help you. I can help you. That's my area of specialization. Let's look at what we have today. What's the topic we have today? Today we have the factors affecting the rates of reaction. The factors affecting the rate of reaction. One great man, his name is Licatilia. Okay, Licatilia is a French man. He's a French chemist. Okay, he is the father of anything rate of what? Chemical process, or the factors affecting equilibrium in a chemical system. All right. So let's look at what we have here. Under the factors affecting the rate of reaction, we have temperature. Number one, is the temperature high? Is the temperature low? Remember, high temperature favors what? Endothermic reaction. Low temperature favors what? Exothermic reaction. High temperature what? Leads to the what? The easy mobility of the molecules in a state of matter. Is it in solid state? Is it in liquid state? Is it in gaseous state? It leads to the what? The mobility. They move faster when the temperature is high. Okay, so you can see the part that temperature plays in the rate of chemical reaction. Okay, that's that for that. The next we have is the concentration for solution / pressure for gases. That's the concentration of the solutes in the solution. Now, high concentration, is it high? Is it concentrated or is it dilute? When I pour you concentrated acid now, and when I pour you dilute acid, which one will burn you pass? Which one will corrode your skin pass? It's the concentrated acid. So you can see how it affects the rate of chemical reaction. The concentrated one quickly burn your skin up and down, but the dilute acid will take time. If you go find carbonate pour for your face, you know, like Coke or all those irritated drinks, soft drinks, pour for your body, pour for your face. If they pour you dilute acid, okay, if you don't quickly harm you like that. So you can see how the concentration of solute in a solution. This one is for solution. Then for gases, pressure is for only gases. Okay, pressure is for only gases. Though some kind of reaction, there are some kind of reaction where pressure is needed. Hey, this thing don't come out. There are some kind of reaction where pressure is needed. Okay, there are some kind of hope I'm audible, guys. There are some kind of reaction where pressure is needed. All right, so pressure is needed for some kind of reaction to occur. For example, the hydrogenation of vegetable oil. Okay, is usually you usually need a high pressure for that reaction to occur. That change to occur. All right, where vegetable oil is turned to margarine or butter. It's hardened through an industrial process called hydrogenation of vegetable oil using a catalyst called what? What's the catalyst use? Drop the catalyst use in the comment section. We already treated catalyst, industrial processes and catalyst use. We already treated that. Okay. All right. Another factor that affects the rate of reaction is surface area of the reactant. I will teach you what it means when they say surface area of the reactant. The surface area of the reactant is the form of the reactant. How does it appear? The contacts. To what extent do you give the two reactants or all the reactants? To what extent do you give them contacts? How well can they contact each other? For example, okay, if you bring salt, though this is not a chemical process, I'm just giving an instance. Okay, if you bring salt and your normal salt at home, sodium chloride, you put it in a hard form. Okay, all those olden days salt will be like ball of salt. If they want to put on for food, they will use knife or spoon. They scrape and they put inside the food. Don't be now when they get salt. Maybe say fine salt, finely divided salt. No, that time a solid salt that they get. It will just go be like ball. You carry that salt, you throw them inside bucket of water. It go dissolve immediately. It not go dissolve. It not go dissolve. But when you grind it, you give it a fine appearance. You increase the surface area. That's the salt can spread. Okay, it spreads better. The water can come in contact with much more parts of the salt. The reaction becomes faster. The dissolution becomes faster. Same thing with cube sugar and finely divided sugar. If you put cube sugar inside water, you go look at like this for inside the water. You know, go dissolve finish. Okay, it will dissolve slowly. But when you finally divide the sugar, you grind it and you pour it inside the water, because there is now more surface area. It spreads. Okay, more water will contact more parts of the sugar. Okay, and this facilitates quick dissolution. Now the same thing for chemical reaction, which I just explained. So that's how the surface area of the reactants affect the rate of reaction. Therefore, catalyst. Is catalyst introduced into the system? Remember, a catalyst is a what? A substance that facilitates the rate of chemical reaction. By doing what? How it they facilitate them? How it they speed up the rate of chemical reaction? By lowering the activation energy. Maybe for example, for me to blow your eye, okay, for me to blow your eye, I am going to require, let me say, the energy that I'm going to require to blow your eye is 40 what? Joule. That's what I'm going to require to blow inside your eye from here now. For this your skin, I'll blow your eye now. Now 40 joule I will need. But if I can't put catalyst into the system, you know what this catalyst go do? The catalyst go come reduce the activation energy. Okay? That 40 joule where I need to take blow your eye, the catalyst go come reduce that 40 joule. It go come reduce them to like 10 joule. 10 joule. So because it don't reduce the energy where they require for the reaction to occur, the reaction will go on dey faster. Okay? Faster. So before, if now like this I go take blow your eye, because the activation energy don't reduce, I don't need to stress myself to find energy where I want to blow your eye again. It will come go faster. I will blow your eye once. You understand? So that's what catalyst does. Reducing that energy required to start up the chemical process. That's how it speeds up the rate of chemical process. And catalysts are not involved in the reaction. They are not directly involved in the reaction. The same way you put catalysts, now the same way you go recover them from the reaction after the whole reaction don't finish. After the whole chemical process, you are going to recover the same catalyst. You recover it. That's why you don't use up catalyst. Catalyst no dey waste, because after the reaction you go recover them back, keep. You go recover them back, waiting, keep. You don't hear say catalyst for the catalyst when they dey for motor for exhaust. You don't hear say the catalyst finish. Person turn and tell say my catalyst don't finish. No. The only thing you can hear is that the catalyst don't bad or the catalyst don't weak. Okay, because it's not used up. They know they use up catalyst, because the same way you put on, you know they take part in the chemical process, so it's not lost during the chemical reaction. It's recovered as you take put on. So another factor that affects the rate of reaction is the nature of the reactant. What is the nature of the reactant? Is it a highly reactive reactant? Is it an oxidizing agent? Is it a powerful oxidizing agent? Is it a powerful reducing agent? You can see bond type and complexity. What type of bond does this particular reactant strive to attain? Does it have affinity for electron? That's what we determine how fast the reaction is going to occur. For example, I carry potassium now, put inside water. I carry potassium waiting now, put inside water. You know that potassium is highly electropositive. Potassium is the most electropositive element. The most electropositive element. You know potassium, the atomic number is 19. So since the atomic number is 19, if you do 2, we are drawing the orbital diagram. Now if you do 2, pair the first 2 electrons, you draw another orbital, you pair it, you draw the third orbital, you now pair another 8. 8 plus 8 is what? 16. 16 plus 2 is what? 18. That's the outermost share, we now have what? The outermost share, we now have 1. That makes it 19. So what is it going to do? Potassium is very fast to donate that electron. You understand? It's very fast to donate that last electron it has to achieve a what? An octet stability. Alright? Through the bond. Okay? So immediately you put it inside water, it quickly donates what? That last electron. Okay? It's very spontaneous, very fast. Okay, very rapid and explosive. It donates it. Immediately as it donates that 1 electron, because it's striving to become stable by all means. Not the only one make it know this stable, unpaired. 1 unpaired electron. Okay, now make it know this stable. So immediately it donates like this. Water go accept them. And compound don't form. So that's it. You can see the nature of the reactant. You can see that potassium is highly electropositive. Potassium is a strong reducing agent. Alright, so that's that for that. Then for the presence of light, for example, for photosynthesis or for photochemical reactions such as photosynthesis. Now one example. The presence of light there, if light no dey, the reaction will occur. So I've just walked you through all the rates, expanded everything, the factors that affect rate of chemical reaction. You know, go tell me say you don't understand how any of them for here, inside the 6 of them, any of them, temperature, concentration for solution, pressure for gases, surface area of reactants, catalyst, nature of reactants, presence of light, and so on. You know, tell me say you don't know how they affect the rate of chemical reaction, the rate of reaction. You know if you tell me, because I don't explain everything to you. All right. Now let's look at each of them one after the other. We are going to look at temperature, concentration, surface area, catalyst, nature of reactants, everything one after the other. I don't already explain everything for you, so I'll be very fast here. All right. I don't feel explain everything, but I'll be very fast. All right. So the effect of temperature in a reaction. What's the effect of temperature? Increasing temperature raises particle kinetic energy. Don't be waiting I explain for you. I say when you increase the temperature, the molecules, okay, the molecules or the particles inside the, inside the compound or the reactant moves faster. okay, there is more collision. There are more collisions between them, all right? So that's it. Immediately you increase the temperature, more collision. Both you now increase the what? The intramolecular force. The molecular force inside them will come increase. Okay, the intramolecular force will now be higher than the what? Intermolecular force. So you see, then they are allowed to move. Okay, the molecules now move because you don't energize the molecule from inside. Okay, but when the intermolecular force, that's the force outside the molecule, is greater than the intramolecular force, such particles don't go move. Okay, they find it difficult to move. That's what occurs in solid. The intermolecular force is more than the intramolecular force. That's the one outside is more than the one inside. Inter is outside between molecules. Intra is the one inside the molecule itself. So when the one inside the molecule itself is high, the molecule moves. But when the one outside the molecule is higher, the molecule doesn't move. Okay, it's difficult for the molecules to move about. That's what you see in solid. All right. So more particle collides with sufficient energy to overcome activation energy. You can see. So the more particle collision of high temperature. Okay. Reaction rate increases exponentially with temperature according to Arrhenius equation. Reaction rate increases exponentially. That's it continues to add. As you increase temperature, it increases according to what? Arrhenius what? Equation. The effect of concentration / pressure. Higher concentration equals more particle per what? Unit volume. That means when the concentration of the reactant is higher, you have more particles in the system because it's of high concentration. All right. So when you now have more particles, you now have more frequent collision because people many. If we be only 3 inside this room, the possibility for us to waka jam each other, it go hard. But when we reach like 15 inside this room, the possibility say if this one waka pass, it will jam me, or if this one pass, it will mash me. The possibility will increase. This one is concentration for solution. Then for gases, pressure. All right. For gases, higher pressure compresses particle into smaller volume. When the pressure of the system is higher, it compresses the particle into smaller volume, so increasing collision frequency. The frequency of the collision now increases. The extent of the collision now increases. That's why when you put a gas inside a cylinder or a gas container, the gas is constantly, when the pressure is high, the gas is constantly bombarding the container, bombarding the cylinder 247. This is the what? Because of the high frequency of the collision attained. All right. So both leads to what? Faster reaction rates. Both. Okay. When you increase pressure for gas or you increase concentration for solution, they lead to what? A faster reaction rate. All right. The effect of surface area, okay, finely divided solids, that's when they are in powder form, expose more particle for collision, like I said, expose more parts of the reactants to one another. They are exposed better to one another as compared to when they are in just whole solid form. Large surface area equals more effective collisions. So when the surface area is large, you have more space to mix. You have more space to marry. Okay, you can touch every other. It's just like when you are with a guy in a room or a man and woman they inside room, okay, and the man wears suit, the woman wears suit, the man wears suit, the woman wears suit, and they want to do that thing. If since they want to do that thing now, with the man hand go fit dey go all the woman body, or the woman hand go fit dey go all parts of the man body. No, the man will not be able to penetrate. So let's say the man is the reactant, the woman is the reactant, it's another reactant, and two of them they want to react. If they don't put those coats and those suits with them wear, their hand don't go fit touch where they're supposed to touch. So that made that thing for happen. All right. So it's just the same here. If you don't divide the reactants into fine powders, the other reactants don't go fit access the part where you access make the reaction for occur. They don't go fit marry well. They don't go fit come together homogeneously. All right. So that's it. And in turn, this leads to what? Faster reaction. For example, powdered zinc reacts faster with hydrochloric acid than a lump of zinc. That's than a what? A lump of zinc. That's one wrap of zinc. Might use a wrap of a bowl, a wrap of fufu to explain that for you. One wrap of zinc or one fufu of zinc. Okay, one fufu of zinc. A powdered zinc reacts faster with hydrochloric acid than one fufu of zinc. Now let's look at catalyst. When the catalyst is added, what happens? Catalysts provide an alternative pathway with low activation energy. For example, the types of catalysts they include homogeneous catalysts, which have the same phase as the reactant. For example, hydrogen ion in ester hydrolysis. All right. So homogeneous catalyst means that homo means the same or one. The same. Homogeneous means one that's the same phase as the reactant. So the catalyst has the same phase as the reactant. So hydrogen ion in ester hydrolysis, the catalyst and the reactant has the same what? Phase. But when it comes to heterogeneous catalyst, okay, we have 3 types of catalyst majorly. Okay, when we go to heterogeneous catalyst, hetero means 2 or different. Okay, it means that the catalyst and the reactant have 2 different phases or different phases. All right, they have different phases. All right, for example, the nickel in hydrogenation, whereby you add the finely divided nickel during hydrogenation of vegetable oil to catalyze the process, to make the process faster, and margarine is formed. So they have different phase. Okay, so homogeneous catalyst the same phase, For example, hydrogen ion in ester during hydrolysis. This is the formation of ester, whereby an alkanol is reacted with a mineral acid to form ester. So the third type of catalyst we have is enzymes. Okay, these are biological catalysts. Okay, they are highly specific. So enzymes are highly specific in nature. This particular enzyme can only digest or can only speed up one particular rate of reaction. Another enzyme can only digest or speed up another rate of biological reaction or another biochemical process. So enzyme with the body many. Go ask people who study biochemistry now. There are many. So if you are studying biochemistry, your head there. If you know sabi memorize biochemistry, will hard you well because you have lots of pathways in biochemistry. So the catalyst does what? They speed up the rate of chemical reaction without being consumed. Like I taught you earlier, they are not used up. All right. The next we have here is moderating the rate of reaction. Okay. Lowering temperature slows reaction. When you reduce temperature for reaction, the reaction will slow down because you know within high temperature they cause now. When you increase temperature for reaction, what did they happen to the particles? What did they happen to the intramolecular force? Intramolecular force will come be higher than the intermolecular force, so they will come start to move. All right. So diluting reactants reduces concentration. So when concentration fall, the number of particles and molecules inside the system, inside the solution go reduce. So when lesser people dey inside room here, collision no go dey. We know if they jam each other, we don't come many again. Okay, possibility no they say you go pass, your body will touch me, or you go pass, you go mash me. No, other than when we find many inside the room. Okay, so reducing pressure slows gas phase reaction. So pressure are mostly for gas. Okay, so when you reduce pressure for gas system, it reduces the frequency of collision. Okay, because reduced pressure reduces intramolecular forces in gas. Okay, intramolecular forces in gas. The final we have here is removing catalysts or inhibitors can moderate rates. Removing catalysts or inhibitors can what? Moderate rates. Okay, so it depends on what you want to achieve. Are you trying to achieve more products, or are you trying to achieve more reactants? Are you trying to move the reaction from left to right, or you are trying to move the reaction from right to left? Do you want more products? Do you want more reactants? That's what's going to determine if you are going how you are going to moderate the rate of reaction. Okay, are you removing catalysts? If you remove catalysts, that means that you've done what? You've reduced the rate of the reaction that the catalyst is favoring. Are you introducing inhibitors that will slow down the rate of the reaction? Depending on what you want. That's why it's called moderating reaction rate. What do you want to achieve? Now, you know that lowering temperature will slow down the reaction. So, for example, a reaction that is too fast and you want it to slow down, you reduce the temperature. Okay, if the reaction is dependent on temperature. Another one is if the reaction is too fast and you want the reaction to slow down and you have concentrated reactants in the reaction, you dilute the reactants and reaction will slow down. If you want maybe fast, you increase the concentration of the reactants. Okay, by concentrating the reactants. Okay, so for a system where gas is involved, okay, reducing pressure slows the reaction. Is the reaction occurring very fast and you want it to slow down, you reduce the pressure in the gaseous system. That's it. If the reaction is going too slow, you want it to be fast, you increase the pressure. That's it. The same thing for catalyst. You want me fast, you add catalyst. You want me slow, you introduce inhibitor. Reaction rate curves. Concentration versus time is the first curve. All right. The curve slope downwards as reactants are consumed. The curve does what? It slopes downward as reactants are what? Consumed. Inside, as you use up the reaction, the concentration versus time. Okay, concentration will fall because the reactants are used. Okay, it slopes downward. Okay, it falls with time. Okay, then rate versus time. What happens? Rate versus time. The rate decreases as reactants are used up. The rate decreases. The rate and time of the reaction decreases as the reactant are used up. Okay, so as you use up reactants, for example, you on gen, for example, as you on gen, as your reactants, the fuel and air, as you are using up your fuel and your air required for the combustion of petrol in a closed system or in the cylinder of the engine, as you use up the fuel, the reaction will reduce. Okay, the reaction will wait. The rate and the time of the reaction will reduce. Again, when it will reach, the gen will stop because everything don't finish. They have been used up. Okay, so steeper slope equal to what? Faster initial rate. Steeper slope, that's the one we go up past. Okay, the slope we go up past. The slope we go up past. Higher slope. It's like saying the higher slope is what? Is the fastest initial rate. Okay, the fastest initial rate. That is high. It moves very fast. Okay, solving simple problems involving rate of reaction. For example, if doubling concentration doubles rates, that's you double concentration now, the rate of reaction will double. Reaction is first order with respect to that reactant. You see the name where they give them first order. JAMB, they said this question well. If doubling concentration doubles rate, reaction is first order with respect to reactant. That's for reactant side. If doubling concentration quadruples rate, you can't double concentration now. It can't quadruple the rate. The rate can be times 4. The reaction is second order. That's times 2. Times 2 of the effect of doubling concentration is first order. Times 4 of the effect of doubling concentration is what? Second order. Put on for your head though. It's easy. Relation of the rate of reaction to kinetic theory. The first we have here is particles are in constant motion. That's what I always say. Okay. but depending on the states, okay, that's what we determine the rate at which the particles move. In solid, the particles move slower because they are tightly packed. You know, get the one where we say the particle no they move. Even solid, the particles still move, okay, because to some extent there are some intramolecular force inside the particles. All right. So the second here is reaction rate depends on collision frequency and energy. Collision frequency, how often they jam, how often they collide particles, how often. That's the collision frequency. And another one again is the energy of the system. What is the Gibbs free energy like? Is it an endothermic process? Is it an exothermic process? Then number 3, only collisions with energy greater or equal to activation energy and correct orientation leads to what? Reaction. What is correct orientation? That's the balance between Gibbs free energy, enthalpy, and entropy. That's the word correct orientation. So only collision with energy, that's collision plus energy. Energy is required, okay? Greater or equal to activation energy, okay? So this collision plus energy will now give us the activation energy to start up the reaction. This collision of energy must be greater or equal to activation energy, okay? It must be greater or equal to what? Activation energy. If the collision energy or the energy of the system is not greater or equal to the activation energy, the reaction cannot start. For example, activation energy is the energy required to start a chemical reaction or a chemical process, okay? Let's say the activation energy is 30 joule, okay? And the collision with the energy within the system can be 25 joule. The reaction will start up. No, because it never reached the activation energy. Okay, so for that reaction to start, okay, for the process to start occurring, you need to the energy of the system to get to that what? That activation energy, which is 30 joule. It must be either on the 30 joule or greater than 30 joule. That's why you are seeing greater or equal to here. All right, that's that. What is the significance of activation energy? Like I just explained to you, but let's dive in deeper, okay? Activation energy is the minimum energy required for the reaction to occur. That's for the reaction to start, for the reaction to be established, is the minimum energy required, okay? And it determines sensitivity of reaction rates to temperature change. It determines the sensitivity of reaction rates to temperature change. So it determines how the reactant and products are going to respond to temperature change. That's if you increase the temperature or you decrease the temperature. It's activation energy that determines how the reactants are going to, respond to this temperature change, all right? So high activation energy, E stands for energy, this small e stands for activation. High activation energy is equal to or is directly proportional to reaction strongly dependent on temperature. So when you require a high activation energy, the reaction is dependent on temperature, is dependent on high temperature to occur. And such a reaction is termed what? Endothermic reaction, because heat is required. All right. So the deduction of activation energy from Arrhenius equation, remember what Arrhenius said through this equation? He said that this K, which is our constant, is equal to, that's for a reaction to be constant, AE minus EA over RT. In the ideal gas equation, what is the meaning of RT? In the ideal gas equation, can you remember? We already treated that, okay? In the ideal gas equation, what's the meaning of RT? This R and T. Plot INK versus or against 1 over T, all right? And the slope of this graph or the slope of this curve, you are plotting in a straight line like this, like Sharp's law, straight line like this, straight line, because this is directly proportional. It's a direct proportionality, directly proportional. INK is directly proportional to 1 over T, all right? So the slope is equal to minus EA over R. That's the slope, Shikina. Now that we have understood the factors affecting the rate of chemical reaction, chemical processes, let's now take some JAMB must repeat questions to test the knowledge we've acquired so far and measure our readiness for JAMB UTME 2026. JAMB must repeat questions. Question 230. How does increasing temperature affect the rate of a chemical reaction? A. Decreases rate. B. Increases rate. C. No effect. D. Stops reaction. What's the answer? Drop the answer in the comment section. Question 231. Doubling the concentration of a reactant in a first order reaction will what? A. Double the rate. B. Quadruple the rate. C. Half the rate. D. Have no effect. You were taught now. What's the answer? Drop the answer in the comment section. Question 232. Increasing pressure in a gaseous reaction is equivalent to what? A. Increasing surface area. B. Increasing concentration. C. Decreasing temperature. D. Adding a catalyst. You were taught. What's the answer? Drop the answer in the comment section, my scholar. Question 233. Powdered zinc reacts faster with dilute hydrochloric acid than a lump of zinc because A. Powdered zinc has low activation energy. B. Powdered zinc has large surface area. C. Powdered zinc is more reactive chemically. D. Powdered zinc dissolves faster. What's the answer? You were taught now. So drop the answer in the comment section, my scholar. Make me proud. Question 234. A catalyst increases the rate of a reaction by what? A. Increasing the temperature. B. Lowering the activation energy. C. Increasing the concentration. D. Changing equilibrium position. What's the answer? I taught you now. I just taught you. So what's the answer? Drop the answer in the comment section, my scholar. Question 235. The minimum energy required for a reaction to occur is called what? A. Threshold energy. B. Bond energy. C. Activation energy. D, reaction enthalpy was the answer. I just taught you now. Was the answer? Drop the answer in the comment section, my scholar. Question 236. A concentration versus time graph. The slope at any point represents what? Activation energy, rate of reaction, concentration of product, order of reaction. Was the answer? Drop the answer in the comment section, my scholar. I taught you now. I just taught you. Question 337. From a plot of INK versus 1 over t, the slope is equal to what? A, EE, B minus EA over R, C R over EE, D minus R over EE. I just taught you now. Drop the answer in the comment section, my scholar. No let JAMB jam you this time around though. Get this material. Get this short, simplified, concise, straight to the point note. It's available in physics, chemistry, biology. You no go waste your time to read. It's available in English also. Leaving no stones unturned. Everything for the JAMB UTME syllabus. We cover everything. Just 350 slides. Small slides like this, as you be seeing for your screen. As colorful, beautiful, good looking, so sweet to read. If they read our slides, to read with the hungry you. No be all those dry textbook where you carry they read. Very short, everything. All you need 9 days. So no let JAMB jam you this time around. Don't repeat this JAMB again in 2027. Take action now. Even though you have 2 weeks left to prepare for your examination, your JAMB UTME examination, I have a plan that will work for you. Last minute plan. Okay? So enter my DM, may you get all these things. May you start now to prepare. I swear. If you follow my pattern, if you follow my plan, you don't score well. You know your score don't make sense. See, carry police arrest me. I've given you that free ticket to arrest me. I've given you the permission. Carry police arrest me in the end. Let me tell you. Because I believe in what I'm disseminating to you. I believe in what I'm spreading out to you. So get this lesson note, short, concise lesson note. This is not the time to read textbook. If you are reading textbook now, you are in abject error. You are in error because it's going to make you fail. It's going to make you fail. Now you want to read textbook. Exam where you supposed not to prepare for since November last year or December last year. Then now when you be saying almost 1 month remaining for the exam to start. Now you want to start to prepare with big textbook. No, now come on, make I help you. Come on, make I give you plan. I've been doing this for almost 4 years now. Okay, I am well experienced. And mind you, I took JAMB 7 times, so I'm very experienced when it comes to this exam. All right, so let's go. Come to my DM. My phone number is on my bio. You go to my bio, you see my phone number for that place. So add up and send me a message or look at your screen. You will see I'm somewhere around your screen. Send me a message. JAMB 26 candidate.